Hi, welcome back to another video. Today I'm going to speed through organic nomenclature, or how to name these hydrocarbons we've been looking at. So we're going to review the homologous series, and today I want you to focus on how to name basic alkanes, alkenes, alkynes. I am going to go further than that in this video, but due to a lack of time, we're not really going to practice some of the more complex structures. But with that being said, it is important for most of you to understand the basics of naming organic compounds, and you will come across some of these compounds in more advanced sciences. So we're going to go over the basic naming nomenclature rules, and I'm going to give you lots of examples. So I sometimes find that these diagrams are helpful, but hydrocarbons really break off into two main types. You have your straight chain, so just carbons linked together, and you have your aromatics or your ring carbons like benzene. Your straight chain can break into two categories, saturated and unsaturated. A reminder, unsaturated hydrocarbons are your alkenes and alkynes. It means they have a multiple bond, at least one double or triple bond. Saturated have all single bonds, and that falls into our alkane homologous series. And again, each of these have their own formula, and they also get their own suffix or ending. Alkanes end with A and E, alkenes end with E and E, alkynes end with Y and E. So just with our inorganic compounds we looked at earlier in the year, we already have talked about covalent and ionic naming, or nomenclature. The International Union of Pure and Applied Chemistry, or IUPAC, is still the governing body who made up these rules. And again, the purpose of it is so that someone in America talking about hydrocarbons is talking about the same chemical as someone in Russia, for example. So there's a few different components for organic compounds. We have the prefix, or the beginning root. This is going to indicate the number of carbons in our chain or our ring. The ending root, or suffix, this is going to indicate what series or class the molecule belongs to, such as the A and E, E and E, Y and E that I just pointed out for our homologous series. There's going to sometimes be a number in front of the name. So it's a little odd to see at first, but these compounds can start with a number, and this is going to indicate where the multiple bond, or what's called a functional group, is located. Functional groups are a fancy term for something like a chlorine or a hydroxide group that is added to one of these chains. And sometimes you might see other prefixes like di and tri. So if you have, for example, two chlorines on your molecule, you would use the prefix di just to indicate that there is two chlorines and not one chlorine. To help you out, there is a table, table P in your reference table, that gives you the prefix that we're going to use. It depends on the number of carbons, so you are going to need your reference table so that you can reference this. You're also going to see that you're already familiar with some of these prefixes. For example, propane, that's the gas that we use in grills. Butane, that's the gas found in lighters. Octane, you might see that word on a gas pump for your car. And here's some steps for you to follow when naming organic compounds. The first thing and most important thing is to determine the number of carbons in the longest unbroken chain. So if you can trace all the carbons without lifting your pencil, no matter if they bend or whatnot, that is an unbroken chain. You're then going to look up the number of carbon atoms in table P for the correct prefix. You're going to apply the appropriate suffix. So suffix meaning the ending. So if it belongs to alkanes, it would have that A and E ending. Identify if there's a carbon that has a double or triple bond and what carbon it starts on. In order to determine what number to use, you number the carbon chain starting from N at one end and then do it from the other end, and you're going to use the smallest number for that carbon that the double or triple bond occurs on. This is a fully included list of suffixes that you could use. This is also in your reference table for tables Q and R. I'm going to focus again on the basics, so alkanes, alkenes, alkynes, but alcohols are going to have an OL ending, aldehydes an AL, and we're going to talk about some of these oic acids, so anything that ends with oic acid is our organic acid, and our next video is actually going to cover all of these, which are functional groups. There are a couple exceptions. The halides are actually named with a halogen prefix. I don't know why they're different, but they are. But for the most part, the suffix is what indicates the class of compound. As you saw previously, some of these molecules have branches coming off the main chain. These are called side chain or branches. These chains get named separately from the main chain. The name of the side chain is the prefix. So from table P, based on the number of carbons with a YL ending. So for example, if you have a 1 carbon side chain, the prefix for 1 carbon is meth, and then you would end YL on the end for the side chain to be named methyl. Oh, and here's another example. If you have a 3 carbon chain, 3 carbons get the name prop, you add YL to the end, and a 3 carbon side chain would be called propyl. The side chain name actually goes in front of the main chain name with a number to indicate which carbon the side chain is located on. And now we're going to do a couple examples. So starting with the most basic compound that we can look at, that is an alkane. So here we have a 3 carbon chain. Again, you determine the longest chain by basically following the carbons, and if you don't pick up your pencil, that's a full chain. So 1, 2, 3. And if we go to table P, you're going to see that 3 carbons have the prefix prop. Because this is an alkane and it has all single bonds to hydrogens, it gets an ANE ending. So again, prop comes from the fact that it's a 3 carbon compound. ANE indicates that its class is alkanes, all single bonds, and we get the name propane. Alkanes are fairly straightforward. Alkenes, we have to add another step because now we have that double bond. So our first step is always to figure out how many carbons we have in a single chain. So we have 1, 2, 3, 4. So we're going to have a 4 carbon chain, which means this compound is going to get the prefix but. So if you go to table P, you're going to see that the prefix for 4 carbons is but. There is a double bond, an unsaturated hydrocarbon. Double bond means this molecule has to have an alkene suffix. And now we have to number where the bond occurs. So you're going to count the chain both ways. 1, 2, 3, 4. Or we can number it this way, right? We could flip this 180 degrees. 1, 2, 3, 4. You take the lowest number that the double bond occurs on, which would be carbon number 1. Your options were carbon number 3, reading it from this way, or carbon number 1. You always take the lowest number. And again, the point of this is to keep everyone on the same page. If we number things the same way, we're talking about the same compound no matter where we are, which makes this 1-butene. Because we're on carbon number 1 is where our double bond is. The ENE ending indicates that the one is telling us there's a double bond, and again, but for 4 carbons. Here's another example of an alkene. So we have 1, 2, 3, 4 carbons again. So our prefix for 4 carbons is but. We're also going to take a look at where the double bond is occurring. So we know this is an alkene, and this is going to get the alkene ending because there's a double bond. And we count 1, 2, 3, 4. And we count this way, 1, 2, 3, 4. No matter which way I count, the lowest number for the double bond occurring is on carbon number 2. So we have a 4-carbon chain, which makes this bute. Double bond ending, so we have E and E as our ending. Double bond is located on carbon number 2, which makes this 2-butene. Again, the number 2 tells us where the double bond is. Bute tells us 4 carbons. E and E tells us there's a double bond on carbon number 2. And an alkyne example. So again, same thing. I'm going to count the chain. 1, 2, 3, 4, 5, 6, 7, 8. Just a reminder that if you see bonds going to nothing, this is all hydrogen. You don't have to actually draw the H's for hydrogen. It is assumed to be hydrogen. But we have an 8-carbon chain. If we go to table P, we're going to see that table P says the prefix for 8 is oct. This has a triple bond, which means it's going to get a YNE ending. This is an alkyne. And then I need to figure out the location of my triple bond. So I'm going to count my carbons. 1, 2, 3, 4, 5, 6, 7, 8. Or I can count it from this direction. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to take the lowest number, which is carbon number 3. So 8-carbon chain is oct. YNE ending for the triple bond. Triple bond is on carbon number 3, which makes this compound 3-octyne. Again, location of the triple bond. This tells me it's a triple bond that we're indicating. Oct tells me it's an 8-carbon chain. Alright, so this is a couple examples just to show you why the numbering is important. So if we take a look at the first example, we have 1, 2, 3, 4, 5 carbons. And we have the triple bond happening on carbon number 1, or if we count from this way, 1, 2, 3, 4. We always take the lowest number, and this is 1 pentene. So 1 pentene, because again, triple bonds on carbon number 1, there's 5 carbons, which gets the prefix pent from table P. YNE because it's a triple bond. Now if we look at this one, we have 1, 2, 3, 4, 5 carbons. So again, this is pent. It's pentyne because there's a triple bond. But this time, if we count 1, 2, 3, 4, 5, 1, 2, 3, picking the smallest number, this is 2-pentyne, triple bonds occurring on carbon number 2. If we look down here, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Again, the lowest number is 2-pentyne. These two are the same molecule, they're just flipped 180 degrees. This is why it's important to count your carbons in both directions, because you always need to pick the lowest number carbon for the triple bond to occur on. Alright, now here's an example of a branched hydrocarbon. So we have 1, 2, 3. Carbon chain, we could also count this 1, 2, 3. But either way, you have a 3-carbon chain, so this is going to be a prop. We have all single bonds, so A and E ending. Our branch is on carbon number 2. 1, 2, no matter which way we count. Branches get named by the number of carbons in them, so this has 1 carbon, so it's meth, and they get a YL ending for methyl. The name of the side chain goes in front of the main chain, so this ends up being 2-methyl propane. Propane for our 3-carbon chain, methyl for our branch, and it's on carbon number 2. And here's our last example. I just want to show you an example of a functional group. So here we have 2-pentanol. So pent, we have 1, 2, 3, 4, 5 carbons, all single bonds, AN. And then we have an OL ending for this hydroxyl group. OL indicates that there is an alcohol, and it's on carbon number 2. So this is how you would name a functional group. The only thing that would change is the ending depending on the functional group. I know this is a lot of information, but again, it's important for future classes. If you have any questions, please let me know. Otherwise, have a good day.